Hey class, here's the example screencast for the Unit 1 Worksheet 3 that you guys have due Wednesday. So let's take a quick look and see if we can figure this out. Some of this is going to be pretty obvious, pretty upfront. Other things are going to take a little bit of, mental stretch. So let's take a look. I'm looking at figure 1. I have A and B. Box A has a bunch of dots in it. Box B has, of course, many more dots in it, especially since box B is bigger, so it holds more, dots. The dots represents the matter. So A versus B, when it talks about mass, clearly B has a higher mass because it has more things. So when we're talking about the relationship between A and B, then of course B is bigger. And the reasoning is, of course, there's more dots. And that's pretty obvious. Volume, we're talking about A and B, and again, B is definitely bigger box. So it's just a bigger size. There's no confusion about that. Now the question comes down to density. Now if you remember from density, density equals mass divided by volume. So mass divided by volume means how many dots per unit of a box. So if I look at A as my unit of a box, as in my lowest common denominator, now look at this. This is going to be interesting to see. I'm going to actually draw a line. Notice that A is right there to there, and if I extend that over here and draw straight across like this, and then like that to make the bottom portion of B to look very similar to A, what you will notice is that there are the same number of dots in this portion of B, which I made the same size as A. Why is that important? That's important because when we look at those two and compare, the density of A and the density of B means I have just as many dots spaced out in just as much size as A and B. Now it's true that B has more dots in the whole big box of B, but it also has a bigger box. So if we cancel the extra amount of box size of the box with the extra number of dots, we end up with A and B having the same amount of dots per size. So that means that A and B are equal in density. And I would say same number of dots per size box for both A and B. And that's why I put the red line across the B, so you can see I have 4 and then 5 and then 4 for A. That's A there. This is B. And I have 4 and then 5 and then 4 there for B. So they have the same number of dots, or you can think of it as these dots are spaced out a certain way in A, and they're spaced out the same way in B. Okay, now go on to the next question down below this question on the first page, and I want you to use this reasoning to answer those questions then. All right, so let's move on to the next part. So the next part looks like this graph. Students typically have a difficult time understanding graphs. In figure 4 below, the graph shows the relationship between mass and volume for two substances, A and B. Use the graph to answer the questions of these two substances. Have you built a simple two-pan balance shown above? The masses of A substance, A and B. What would happen to the balance if you put equal masses of A and B? Okay, what would happen? Of course, if you put equal masses, that's what the pan balance measures is, say, 10 grams and 10 grams, and then it balances. Okay, so for the first part of this, obviously we're going to say that it's balancing then, if it's equal masses. Now if it's equal volumes, there's the question. What happens if I have, I don't know, let's just pick a number. How about 20 milliliters of A versus 20 milliliters of B? What would happen? Well, here's 20 milliliters over here, and when I go straight up like this, it crosses with substance A. Oops, that's a little tall. Right there. And that goes straight over here to 33. That would be 33 grams, like that. And what would it be here for 20 milliliters of substance B. Like this, it's real close to 10, so that may be 11 grams. Like that. So what happens? Well, the pan of A obviously drops down. Okay? Explain your reasoning. We're using the graph to find out the mass of a certain amount of volume of both substance A and substance B. And we use that understanding then to answer the rest of the questions. Okay, which I'm not going to answer them all for you, but it says find the slope of the line for both A and B. Well, we know what slope is. Slope is rise over run, so that is y2 minus y1 over x2 minus x1, right? So I'll do one of them for you. Let's do A. We're going to do this very simply. Every density has to go through the origin, okay, which is 0.00. So why not use that as one of our like y1 and x1? So then I look up here on the graph and I look for a place where mass and volume cross each other, and I see one right here. Right there, I see 80 grams and 50 milliliters. So for A, I'm going to use this dot for Y2. It's going to be, where are we at here? X is 50, Y is 80, like that. So I do 80 minus 0, because I'm using that as, you guys have got this already. You understand. And then 50 minus 0, which means I get 8 over 5. 80 minus 0 is 80, 50 minus 0 is 50, and cancel the zeros. So whatever that is, hang on a second here, I'll tell you exactly what it is. I think it's 1.6 equals 1.6. Okay? That's for A. You can do the same thing for B. Look for a spot where the line crosses just like we did up here. See if you can find a spot like that, and then use 0, 0 as your y1 and x1. Okay, let's do one more where we can figure out what's going on here. Again, using the graph to answer the question. If you put 10 milliliters of A in one pan balance, what's the mass of B that you'd need in the other pan? Well, here's how you do this. This is so simple. I'm going to get rid of this stuff here. Why does it do that to me every stinking time? Okay, I'm going to erase this and this stuff here, like that. I'm going to go down. It says, again, 10 milliliters of A in one pan balance. What's the mass of B? So 10 milliliters of A, here is 10 milliliters. I go up to A like that, and then I cut over. This is how this works with a graph. I cut over until I hit B, and then I go. Now, if it's 10 milliliters, that's going to be, it looks like maybe 16 grams. Okay, that's my estimate. 16 grams of A. What mass of B would you need in the other pan then? You would need, so that it balances. To make it balance means 16 grams of A, you'd have to put 16 grams of B in the other pan. And that's it. All right, good luck with that. I'm going to move on to the next one. This video is getting too long. Refer to the table of densities to the right to answer the following questions. So sketch a graph of mass versus volume for titanium, copper, and mercury. Again, we're going to use 0, 0, titanium, copper, and mercury. So 0, 0, 1 point is going to be here. Okay. The next point, let's do titanium so you guys can see what's going on. Titanium, if I do 4, let's do this. My density is for titanium is 4.54, and that's grams per milliliter, or grams per cubic centimeter. Okay? If I do a volume of 10, okay, what is the mass? So to get mass, I take density times volume, like this. That means 4.54 times 10, like that, equals 45.4. That's for my mass. So if I do 10 milliliters as 1 point and 40, I get 45.4. So 10 milliliters here, I go up to 45.4. Looks like it's right in the middle. I do 0, 0. I'm going to do a line here to make this look really nice. I'm going to do a red line like that. And then I do, whoa, there we go. All the way through like that. And then I put this down, pick this up, and I say, this is my titanium line. All right? Why don't you do the same thing? You can do that for both copper and mercury. Just making lines here. Okay? All right, good luck. I think you can do the rest of it. So go ahead and knock it out of the park.